All right, we're going to solve some example problems using what we're going to call rotational dynamics. So dynamics is that relationship between torque and acceleration. We're going to first draw a sketch or picture whenever solving a problem. Then we're going to write down all of the given information, but this time for both linear and rotational motion. And I want to use the appropriate symbols. So I want to make sure that I'm translating the problem statement into the symbols that I use in my equations to represent different variables. If you have rolling motion for step 3, I would also encourage you to use those linear rotational bridge equations, so these 3 equations right here, in order to identify even more given information. So you might be given the radius and the angular displacement, and you might not realize that you then also have the linear displacement right away, right? So I want you to use those equations as necessary if you don't feel like you have enough given information, but you have radius and enough information to solve for those analogous terms in either linear or rotational motion. If you need to, in step 4, you can also calculate the moment of inertia using the mass and radius or length of the object if it's not already given to you in the problem. And so you may not realize that you have the moment of inertia too, but if you're given the mass and the radius or the length, you can solve for the moment of inertia, and that might help you get where you need to go. I've listed that equation right here, and I've just given it a k as a constant, as a placeholder. Again, you can use that chart from your rotational inertia notes, or you'll be given the equation or just the value directly. So calculate it if you need to. Step 5 would be to identify the unknown variables that you're solving for using, again, the appropriate symbols. So if you're solving for angular displacement, make it clear that you're solving for delta theta. This will help you when you're solving problems, just translating the problem as you go. Step 6, it's always a good idea to plan your solution before jumping in. And if applicable, really decide at first whether you're going to start with rotational kinematics or torque to solve for your angular acceleration. Remember, this alpha right here, this angular acceleration, is the only variable that connects force, or torque in this case, with kinematics. So this alpha appears in many different equations. It appears in the first one, the second one, the third one, and it appears here in my rotational dynamics or my net torque equation. So alpha is sort of like this bridge between kinematics and forces, and it'll help you solve problems. The idea is to solve first for alpha using either kinematics or net torque. So decide which one you might want to do based on what you've been given and what's most appropriate for you. Then step 7, solve the problem, making sure to evaluate the sign of your final answer and also the sign of all of your values as you calculated them, and make sure to include units and evaluate whether or not your units work out. By following this process, I guarantee that solving rotational dynamics problems will be less intimidating and less mysterious. All right, let's begin by solving an example problem.